Hi everyone. After completing the theoretical part of the first chapter, today we will see the exercise questions, NCERT textbook questions, that is numericals. So before going with that concept, I would like to tell you that please have one formula sheet with you. So that is, after each chapter have a formula sheet with you in any A4 sheet or something. Just write the formula required or which are the formulae present in that chapter. Just note it down so that you can just glance over that. So whenever you have any numericals, go through that daily so that you will be thorough with all the formulae. Okay. So first we will move further. So NCERT first exercise. It is simple one, but you need to calculate by yourself, and if you follow the method properly, then you will get the solution. So first thing what you have to do is you have to write the given data under the numerical. What are the data given? Whether it is distance, whether it is charge, whatever it is. So write down clearly with units properly and then write the formula. After that you have to substitute the corresponding values given, so that you can find the unknown value which is required. Okay. So we will solve it. Accordingly, you also try to solve together. Okay. So first question is exercise 1.1. What is the force between two small charged spheres having charges? So you have to calculate the force. So first write down the data. So given. What you have to calculate? Force. You have to calculate the force. You have two charges given there. So we can write it as Q1, which is 2 into 10 to the power minus 7 coulomb, and Q2 as 3 into 10 to the power minus 7 coulomb. And distance is given as 30 centimeter. So as you all know, you have to write in SI units. So centimeter has to be written in meter. Okay. So 30 by 100, 0.3 meter. So you have to calculate the force required. So Coulomb's law. We have F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. Direct substitution, 1 by 4 pi epsilon naught is nothing but 9 into 10 to the power 9. Q1 as 2 into 10 to the power minus 7 and 3 into 10 to the power minus 7 divided by, so this full is this value, 9 into 10 to the power 9. Okay. 0.3 whole square, or you can write it as 30 into 10 to the power minus 2 whole square. That is also possible. So you have to find out the value, and it comes around 6 into 10 to the power minus 3 Newton. Minus 7, minus 14, 9 and minus 14, minus 5, and then you have here 3 into 10 to the power minus 2. It comes around 10 to the power minus 3 Newton. Okay. So since Q1 and Q2 both are positive in nature, what should be the nature of this one? This has to be repulsive in nature. So it is Q1 and Q2 both are positive charges. So the nature of the force between two charges which are separated by a distance of so and so, that is 30 centimeter, which is given here. So it is repulsive in nature. Okay. So this is actually the simple one in calculation. When you get the square root and all, it will be little difficult, but that calculation anyways you have already studied in your higher classes in mathematics. So write down it clearly. 1 by 4 pi epsilon naught is nothing but 9 into 10 to the power 9, and then substitute the corresponding values. Okay. We'll move on to the next second question. Exercise 1.2. The electrostatic force on a small sphere of charge 0.4 microcoulomb. So what is the data given? As soon as you get the data, just write it down. 0.4 microcoulomb, micro is 10 to the power minus 6, due to another small charged sphere of charge minus 0.8. Just note it down. Here it has to be attractive in nature because Q2 is minus 0.8 microcoulomb. In air is 0.2 Newton. So you are given with the force here. I think you have to calculate distance maybe. So first, there are two parts here. What is the distance between the two spheres, as I have already told? So you have to calculate R. R is required. And second one is, what is the force on the second sphere due to the first one? So the second sphere due to the first one. So these are the two. So if you take it as F12, what is F21? That is what you have to calculate. Okay. So let us start with A. Part A. So we have F is equal to the same formula you have to write, Q1 Q2 by R square. Substitute the corresponding data. You are required to find out the value of R square. So R square will be equal to, just to rearrange, 1 by 4 pi epsilon naught Q1 Q2 by F. R square is 9 into 10 to the power 9 into 0.4 into 10 to the power minus 6. Let us take only the magnitude now. We have not considered any vector form. Okay, but keep in mind that it is minus in nature. Further we need that. Into 0.8 into 10 to the power minus 6. Micro is 10 to the power minus 6 divided by 0.2 Newton. Okay. So just rearrange 9 into 10 to the power 9, 32 into, this I can write it as 4 into 10 to the power minus 7, this I can write it as 8 into 10 to the power minus 7. 8 into 4, 32, 10 to the power minus 7, 10 to the power minus 14, you have 10 to the power minus 5 now, 2 into 10 to the power minus 1. Okay. 16, 14 into 10 to the power minus 9 and minus 14, minus 5 plus 1 minus 4. But note that this is R square. So this unit will be meter square, correct? Now you have to find out the value of R. So just note it down. What will be the value? Square root of 144. So R will be equal to 12 into 10 to the power minus 2 meter, or R is nothing but 12 centimeter. Either you can stop here or you can write this also, because 10 to the power minus 2 meter is nothing but centimeter. So R is 12 centimeter. So this is the distance between two charged spheres which are experiencing a force of 0.2 Newton. I hope it is clear. The simple one. Be careful with the exponential. So now this is the first part. Now what will be the second part? What will be part B? F21. F12 will be equal to minus F21. Correct? But so F12 and F21 both are equal and opposite. So its magnitude will be what? 0.2 Newton. Okay. Attractive in nature. So what it has to be? Why it is attractive? Both are opposite charges, Q1 and Q2. So it has to be attractive, but force experienced is one and the same. Newton's third law. So it has to be 0.2 Newton. Okay. Next, 1.3, exercise 1.3. So for this one, you should have some idea about the second chapter of grade 11, units and dimensions. Okay. 1.3. Check that the ratio K is square by G M E M P is dimensionless. Look up a table for physical constants and determine the value. What does this signify? Okay. So in order to check if it is dimension, whether this ratio has dimension or not, we will go with the basic concept that let us first check what is their SI unit. What is the SI unit of this ratio? Then from there we will find out the dimension of that quantity. Okay. So first is K. What will be K? We have here, what is it? K into Q1 Q2 by R square, correct? K is nothing but 1 by 4 pi epsilon naught. So what should be the SI unit of K? It is Newton meter square per coulomb square, that is K, into E square. E is nothing but charge, electron, so coulomb square, divided by G. G is gravitational constant. So what will be G? F is equal to G m1 m2 by R square. So it will be Newton meter square per kg square, m1 and m2 masses of the two bodies, which this is universal law of gravitation. Okay, chapter 8 of grade 11. So Newton meter square per kg square into me and mp, kg into kg. So this will be cancelled, Newton meter square. So this is what? Unitless. The ratio has no unit, so it will be dimensionless. Since there is no unit, the given ratio is dimensionless. Okay, so this is a simple way how you can calculate or you can find out the value of dimension. So first find out the SI unit. So if it has SI unit, then go with the dimension. Okay, the simple manner. So next part in the same question is you have to find out the value of these this ratio. Substitute the value of K, 9 into 10 to the power 9. Substitute the value of E, 1.6 into 10 to the power minus 19. The value of G. So sometimes all these will be given in the examination. The values will be given. Just you have to substitute and find out the value of that corresponding ratio. Okay. So the ratio, value of ratio. Substitute the value. K square divided by G me mp. So K is nothing but 9 into 10 to the power 9 into E square. E is 1.6 into 10 to the power minus 19 square divided by 6.67 into 10 to the power minus 11, the value of G, and me 9.1 into 10 to the power minus 31 into MP, 1.66 into 10 to the power minus 27. Okay, the value of this we are going to find out in the atoms chapter. How you get this value? MP, mass of the proton. Okay, proton, mass of proton and neutron we consider it as same. So you have to substitute, calculate all the values accordingly and find out the value of the ratio. It comes around 2.28 into 10 to the power 37. The ratio is so high that the ratio, it comes around 37, 10 to the power of 37. Okay, so gravitational force is so small and this is very high in nature, 10 to the power 37, in the range of 10 to the power 37. Okay, this is regarding exercise 1.3. Next question, 1.4, exercise 1.4. This is a theoretical part. 1.4, exercise 1.4 is theoretical one. Explain the meaning of the statement electric charge is quantized. So under the properties of electric charge we have studied this property. So Q is equal to N into E, correct? So the total charge in a system is equal to number of charges into charge of each electron. So where N can be what? Plus or minus 1, plus or minus 2, plus or minus 3, so on. So the total charge in a system is nothing but the product of the quantity into the base charge. What is base charge? Charge of the electron. So it is N into E, where N can be positive or negative integer. So plus or minus 1, plus or minus 2, plus or minus 3 and so on. So it is a product of the basic charge. Q is equal to N into E. That is why we tell that it is quantized in nature. The charges are quantized in nature. So the second part is, why can one ignore quantization of electric charge when dealing with macroscopic quantities or large scale quantities? So when we deal with the macroscopic quantities, what happens is the number will be very large. Okay, so what it means to say that we see that the total system is continuous in nature. So this also we have studied under the properties of charges. So continuation. So when you add small quantities as a together, we see as a whole line. Suppose like this, you have small dots joined very together. If you see nearby, if you see it from very far, what you see, it looks like a straight line. So in the same way, when you add up or when you combine all the charges, so together we say that it is continuous in nature. So when we deal with the macroscopic quantities, we say that it is continuous in nature. Okay. So this is a very simple explanation which is based on the properties of charges. So when a glass rod is rubbed with a silk cloth, charges appear on both. A similar phenomenon is observed with many other pairs of the bodies. Explain how this observation is consistent with the law of conservation of the charge. So what happens when you rub the steel silk rod? What happens is you have the charge transfer taking place. The initial one, if you have any doubt, you can just go with my first video. So there I have explained what will happen and what is how they consider positive charges, negative charges and all. So when you rub, either it might be positive charge or negative charge, whatever it might be, it depends on the material which you are using. So that will be transferred to the other body. So that means to say that the total charge before you do that action and after that remains the same. So it is 0. Positive charges will be on silk and the other one will be on the rod, so glass rod. negative charges. So positive and total charge, positive and negative charges will be 0 before rubbing and after rubbing the silk with the glass rod, so that the net charge remains 0. So this is in accordance with the law of conservation of the charges. So this also comes under the properties of electric charges. Okay, so this is the question 1.5 which I missed in the previous one, which I have written as 1.5 for the previous question. I am sorry with that. So just go with that. Okay, so it is 1.5. Next is 1.7. An electrostatic field line is continuous curve. That is, a field line cannot have breaks. Why? Or you can explain. This is important one, but it is simple. So it is 1.7 in that A. So electric field lines are continuous curve. You cannot have break. Why? Because if you see that when you go away from any one particular point where you have kept the charge, it goes on decreasing. It will not become 0 at one particular instant. No, it is not like that. It keeps on increasing or decreasing as you move away from one point. So it will not have abrupt end. So that is what we mean to say that it is a continuous curve. It will not have any breaks in between. It is not like this. You will have break like this. No, it is not. So it is always continuous. Sudden stop, it will not happen. Very slow down process it is. As you move away from that particular charge, it goes on decreasing. Okay. How it decreases? As a square of the distance. Correct? So we have seen that in the equations, electric field equations. So as you move away, the electric field or the strength of the electric field keeps on decreasing, but it will not have any abrupt end. That is why the field lines are continuous in nature. So this is the first part. What is the second question that you have over there? Explain why two field lines cannot intersect each other. If you have any two field lines like this, at one particular point, or if you see that there is a crossing of electric field lines, it cannot happen because at one particular point, if you see, you can draw two tangent anywhere you can draw, correct? Which is not possible. At one point, there cannot be two directions of electric field. So this is not possible. The same concept you have studied in magnetic concepts in grade 10. Two or more magnetic field lines cannot cross each other because at one particular point where it cross over each other, it will have two directions or two tangents can be drawn, which tells us about the direction. So which is not possible. That is why two or more electric field lines cannot cross each other. Okay. So this is regarding that. A small question, but it is important for give reason, or it might appear as assertion reasoning. Okay, so please be clear with that concept. So this is 1.7. Exercise 1.8. The simple one. 2 point charges QA and QB are located 20 centimeter apart in vacuum, and see that they are opposite in opposite charges, equal and opposite charges, +3 and -3. What is the electric field at the point O, at the midpoint of the line joining AB? So if you have that AB, where you take A as +3 microcoulomb and B as -3 microcoulomb. So what is that you have in the midpoint? Okay. Suppose I have like this. A as 3 microcoulomb and B as -3 microcoulomb. Am I right? Yeah. +3 and -3, and the distance is 20 centimeter. What is the electric field at this point O? now EA. Electric field, it is not force, okay, it is electric field. E is equal to F is you have Q1 Q2 by R square, but E for the electric field you have only one Q, correct? So E is equal to F into Q, or F is equal to E by Q. So you have only one charge over there. So first find out this one, EQ. I'm sorry. EA. It is 1 by 4 pi epsilon naught QA by R square. It is again the same, 9 into 10 to the power 9 into QA is 3 into 10 to the power minus 6. Again here sign is not important when you substitute here, but it is very important when you consider the direction of the electric field. Okay, divided by R is this distance we have now, it is not 20, it is 10 into 10 to the power minus 2 whole square. So 27 into 10 to the power 3, 9 minus 6 divided by 10 into 10 to the power minus 2 is 10 to the power minus 1. 10 to the power minus 1 whole square is 10 to the power minus 2. So 27 into 10 to the power 5 or 2.7 into 10 to the power 6 Newton along OB. Direction is along OB, like this, positive and the negative, correct? So when you have here, it is like this. So sorry, it is Newton per Coulomb, I am sorry, Newton per Coulomb electric field, correct? So next is EB. EB. It is again the same, 1 by 4 pi epsilon naught QB by R square. QB by R square. Again the same, you get 2.7 into 10 to the power 6 Newton per Coulomb. This is also again along OB. Along OB. Because positive and negative. So you have this direction EA. EA also like this, EB also like this. Correct? So what is the total electric field since both are in the same direction? So you can add together. So it is total electric field is equal to 2.7 into 10 to the power 6 into 2. 5.4 into 10 to the power 6 Newton per Coulomb along OB. So it's the total electric field is along OB. Now they have asked to find out, the second part is find the force experienced by that test charge. Since we are test charge means we consider, many a times we consider unit positive charge, correct, in positive in nature. So that is why we have repulsion here and here you have attraction. That is why you get what, OB and OB both are in the same direction, so that you can add at the end. Okay, so it is 5.4 into 10 to the power 6 Newton per Coulomb. SI unit, please note it down, Newton per Coulomb. So now F is equal to E into Q, or E is equal to F by Q. So once you know the total electric field at that particular point, you can find out the force experienced by any test charge which is placed here. So if they have placed 1.5 into 10 to the power minus 9 Coulomb. So this is part A. Part B. So using this one, so please note it down that you have to do this carefully, otherwise this will also go wrong. Okay, so please do it very carefully, don't make silly mistakes. So F is equal to E into Q, or E is equal to F by Q. That is why you have Newton per Coulomb here. E is 5.4 into 10 to the power 6 into what is the charge they have given? 1.5 into 10 to the power minus 9. 1.5 into 10 to the power minus 9. So you have to multiply that, 5.4 into 1.5 into 10 to the power minus 3. So it comes around 8.1 into 10 to the power minus 3 Newton, but it is along OA. Since the direction of force and electric field are opposite in nature, now please see that the total force experienced is along OA. The direction is like this, force experienced is in this direction and the total electric field is in this direction, the opposite. They are opposite in nature, the direction is opposite, so please note it down there. F is along OA and electric field is along OB. Okay. So this is regarding numerical 1.8. Next is 1.9. Exercise 1.9. A system has two charges QA and QB. It is again equal and opposite charges. Minus 2.5 into 10 to the power minus 7 Coulomb. Which are located at points A and B respectively. So you have 3 coordinates here because it is given as A as point A as 0, 0, minus 15 centimeter and point B as 0, 0, plus 15 centimeter. So you should have 3 axis representation. And then what is the total charge and electric dipole moment of the system? The total charge in the system and also calculate the electric dipole moment. So let me represent the 3 coordinates x, y and z. Okay, let it be O, the center. A is 0, 0, minus 15, 0, x is 0, y is 0. So this will be A as 0, 0, minus 15 and charge is 2.5 into 10 to the power minus 7 Coulomb. Let it be B 0, 0, plus 15 and charge as minus 2.5 into 10 to the power minus 7 Coulomb. So you have to calculate the total charge at the center. What is the total charge at the center? Now what will be the distance between 15 and 15? So total distance will be 30 centimeter. Total distance is 30 centimeter. You have to calculate the total charge and the dipole moment. So what will be the total charge at the center? So total charge at the center will be 0 because it is minus, same distance 15 and 15. This is minus, this is plus. So when you add, the total charge at the center will be 0. The net charge QA plus QB zero Coulomb and point B is you have to calculate the total dipole moment. Dipole moment, by which letter it is represented as P. P is equal to 2AQ. 2A is the distance between, so it is like a dipole, correct? Equal and opposite charges separated by some distance. So it is a perpendicular distance we have. You have the direct calculation. You need not find out theta and all, angle, nothing, because it is directly perpendicular in nature. So 2A, that is 30 centimeter, 30 into 10 to the power minus 2 into product of one of the charges. So no need to take the sign. Just take the magnitude. It is 2.5 into 10 to the power minus 7. So 3 into 2.5 into 10 to the power minus 2 and 1, minus 1, minus 1 and minus 7, so minus 8. Correct? 7.5 into 10 to the power minus 8. Coulomb meter. Charge, coulomb, distance in meter. So 7.5 into 10 to the power minus 8 coulomb meter. So this is the total dipole moment of the system. Very important numerical. Just have to consider XYZ axis, 3 axes. Mention the 2 points with the respective coordinates. X is 0, Y is 0, Z is plus 15 and minus 15. Take point B as plus 15, A as minus 15. Then calculate the total charge at the center, which will be 0. And dipole moment P represented as P. According to the definition, it is the distance between the two charges which are equal and opposite in nature and the product of one of the charges. So 2AQ, 2A as a whole distance 30 centimeter. Convert that to meter. Similarly, you have here charge. So and the SI unit will be coulomb meter. Okay. Next is 1.10. The next numerical. Electric dipole with dipole moment. So dipole moment is given as 4 into 10 to the power minus 9 coulomb meter, is aligned at an angle of 30 degrees. So theta is 30 degree. With the direction of uniform electric field of magnitude 5 into 10 to the power 4. So electric field is also given. So 10 to the power 4 Newton per coulomb. So you have to calculate the magnitude of the torque which is acting on the dipole. What do you mean by torque? It is a rotational motion. It is caused due to the couple, two equal and opposite forces acting at different points. So you have like this, any rotational motion. Okay. This again you have studied in rotational motion, grade 11 chapter, rotational motion. In that you have studied about the couple and all. So you have P, theta and E. So we have the formula. Torque tau is equal to P cross E. So it is PE sin theta, product of two vectors. P is nothing but 4 into 10 to the power minus 9 into E is 5 into 10 to the power 4 into sin 30. Sin 30 is half. 4 into 10 to the power minus 5 into 5 into half. 10 into 10 to the power minus 5. So it is 10 to the power minus 4. Electric torque tau, again its unit is Newton meter. Per coulomb and coulomb will be cancelled, Newton meter is remaining. So torque tau is equal to 10 to the power minus 4 Newton meter. Okay. Here it is Newton meter, here it is coulomb meter. PE, SI unit of P is what? Coulomb meter. E is Newton per coulomb. So this coulomb will be cancelled, remaining is Newton meter. So that is why you have SI unit as Newton meter. So tau is equal to P cross E, PE sin theta cross product. This you have studied in vectors, grade 11 again. So substitute the corresponding values. Sin theta value, this you have to know, this will not be given. So this tau is equal to 10 to the power minus 4 Newton meter. So this is the answer for exercise 1.10. Okay. Thank you.